8.2 notes, the tangent ratio. Today we're going to talk about what the tangent ratio is. Our essential question is, what is the tangent ratio and how can we use it to solve for missing sides in right triangles? So let's go over some important vocabulary and stuff. As usual, make sure all of this information is into your notes. The tangent ratio is the ratio of the opposite side of an acute angle in a right triangle to the adjacent side of that same angle. So notice down here we have angle theta that we've talked about, right? Here's our angle that we're referencing. So the tangent ratio of that angle is the ratio of the opposite side to that angle, okay, divided by the adjacent side to that angle. Opposite is across the triangle, adjacent is right next to you. Notice how the hypotenuse is also right next to that angle. We don't consider that adjacent because the hypotenuse is special. That's a special side. It's always across from the right angle. That never changes. So the other side, this side, is what we consider the adjacent side of the right triangle. It's adjacent to that angle theta. And that's what this vocabulary is going over. Opposite, adjacent. Acute angle is any angle less than 90 degrees. So in a right triangle, we will always have two acute angles. Besides the right angle 90 degrees, the other two angles are considered the acute angles in the triangle. And then theta is the symbol that is used to represent an unknown angle measurement. And the symbol looks like this. Kind of looks like a capital O with like a little tilde on top, or a little, like almost like a capital cursive O, if you will. There's a little bit different ways. You can see like this one and this one are slightly different. But that's angle theta, and it just represents an unknown angle measure. Okay, let's move on. More tangent ratio stuff. Again, make sure all this gets in your notes. There's two acute angles in a right triangle, like we said earlier. Let's look at the other acute angle in the same triangle. Which side is the hypotenuse? So this time we're talking about this angle, angle A. Right? We're going to call that angle theta. That's the angle that we are referring to. Which side in this triangle is the hypotenuse? Answer that. Hopefully you said side AC. You would be correct. It's always across from the right angle. So this is our hypotenuse. And that's supposed to be an H. And it's the next question. It says which side is the opposite. When we say opposite, we're talking about opposite the angle that we're talking about, right? So we're talking about this angle theta right here at this time. So what side is opposite to angle theta? Hopefully you said side BC. You would be correct. Opposite means across the triangle. So now this side is opposite, whereas on the last slide it was adjacent because the angle was different, right? That was a different acute angle, reference angle that we were talking about. Now we're talking about the other acute angle up here. So now BC is opposite. Which side is adjacent? Well, that leaves this last side here, side AB. Now this side is adjacent because it's touching or right next to angle theta. And again, to review, the tangent ratio, this is something you need to memorize. This reads like this: tangent ratio of any acute angle. That's what this symbol means. Remember, theta just means any unknown angle measure, or any acute angle in a right triangle. So the tangent of theta is always equal to opposite of theta. So this means opposite side of theta divided by the adjacent side of angle theta. And that is your tangent ratio. So you can see that's represented in our acronym. See, T is for tangent, opposite divided by adjacent. S is for sine, which we'll go over more extensively later, and that's equal to opposite divided by hypotenuse. C is cosine, and that is equal to adjacent divided by hypotenuse. So that's where the acronym SOHCAHTOA comes from. It's to help you remember the different trig ratios that you need to memorize: sine, cosine, and tangent, and what they are. Finding the tangent ratio in a right triangle. So this is important. Let's look at the first bullet point. When asked, for the tangent of an angle, you are not being asked for the angle measure. You are being asked for the tangent ratio of that specific acute angle. Make sure this information is being written down. So when I ask you for the tangent of an angle, I'm not asking you what is the measurement of the angle. I'm asking for you what is the tangent ratio of that angle. That's different. The tangent ratio of any acute angle is that angle's opposite side to its adjacent side. Now let's answer these questions. This first question here, what is the tangent of angle C? So let's go to where angle C is. Angle C is up here. You can see right here in this corner, right? This is angle C. So we would say the tangent of angle C is equal to, we know it's what? Tangent, it is the side that is opposite angle C divided by the side that is adjacent to angle C. What is the side that is opposite angle C? Hopefully you said side AB. You would be correct. That is opposite angle C. So that's opposite. And then what is adjacent to angle C? Hopefully you're saying side AC, and you would be correct. That would be adjacent. Okay, 10 is the hypotenuse. That's never opposite or adjacent. The hypotenuse is always the hypotenuse. So we say that the tangent ratio of angle C, so we shorten it, this is abbreviated, tan C is equal to the opposite side, 8, divided by the adjacent side, 6, which reduces to 4/3. And that's the tangent ratio of angle C, and it's really that simple. Last question on this slide right here says, what is the tangent of angle B? So the tangent of angle B just means that it's the ratio of the opposite side to angle B divided by the adjacent side to angle B. So now remember, angle B is down here in this corner now. So what is opposite to angle B? Hopefully you said 6. That would be correct. That's across the triangle. And what's adjacent to angle B? The side adjacent to angle B. Hopefully you said 8. That would be correct. Remember, 10 is not opposite or adjacent. That's the hypotenuse. So this would be 6/8 or 3/4. So look at that. The tangent of angle C was 4/3. The tangent of angle B was 3/4. They are reciprocals of one another because literally the opposite and the adjacent sides are just flip-flopping from angle to angle. Moving right along, skip a line. Please pause the video, copy down the entire example ahead of time. Make sure you have it down, and let's solve it. Okay, now that you have it written down, it says let's use the tangent ratio to find the length of the missing side. So let's look at the angle that they are giving us, right? Well, first we're solving for angle X, right here. Excuse me, not angle X. Side length AC, which is labeled X. So notice that they give us an angle of 42 degrees. That's great. And notice how they give us the side that is what? Opposite 42 degrees, 14. And notice how we are solving for the adjacent side to angle 42 degrees, or angle C, which is X. That's why we want to use the tangent ratio, because we are involving the opposite and the adjacent sides. We know the opposite side. We want to know the adjacent side. Okay, so essentially the hypotenuse has nothing to do with this problem because we don't know what it is and they're not asking us to solve for it. So this is how we'll write our equation. We're going to write tan, this is just short for tangent, 42 degrees is equal to, again, the opposite side divided by the adjacent side. So now I'm just going to use my highlighter, right? The opposite side is that 14 inches, right? So that's where we're going to plug in for the opposite right here. And then the adjacent side is what we're solving for, X. That's already in pink. That's what we're solving for, so that's what we plug in there. So we're going to write tan 42. Now this is where your calculator comes in. Pull your calculator up. Make sure that is in degree mode. Right here, it should always say DEG. And all you have to do is type in 42. And then you have to find the tangent button. Mine's right here. So I'm just going to click tan. and it gives me this decimal. So we're going to round this to 5 decimal spots. Whenever you do this, you round it to 5 decimal spots. So we're going to say 90040. So I'm going to say 0.90040 is equal to the opposite side, 14, divided by the adjacent side, x. Now this decimal number, I can make it into a fraction by putting it over 1. And then this is a proportion you should know how to solve already. We're going to solve by cross multiplying. So that decimal times x is simply 0.90040. X is equal to 14 times 1, which is 14. And we are simply going to divide both sides by 0.90040. And that's going to give us our missing side length. So we're going to take 14 divided by 0.90040. Whenever you round that tangent number, we want 5 decimal spots. And now we get our final answer. We don't need 5 decimal spots here. Okay, we're just going to say 15.5. That's what it rounds to. So we're going to say that AC, side length AC, is approximately 15.5 inches in length. And now we're on the last example of our notes where we're going to use the tangent ratio to solve for a missing side. Please pause the video and get this all copied down ahead of time so that you can get the rest of this down. So you can see we're given an acute angle of 23 degrees. They are asking us to solve for the opposite side, and we know the adjacent side. So once again, the hypotenuse is not given to us, nor are they asking us to solve for it. So we're using the opposite and the adjacent side, which is the tangent ratio. So we're going to say tan, short for tangent. Anytime we say that, we always have to follow it with an angle measure. In this case, we're going to use the angle they gave us, 23 degrees. So we're going to say tan 23 degrees is equivalent to the opposite side divided by the adjacent side. Okay, so this side, the opposite side is x, and the adjacent side is 27. And we're going to plug in those values here and then solve our proportion, essentially. So we're going to say tangent 23. So now we're going to punch this in our calculator, make sure that we are in degree mode. So let's hit 23, and then we'll hit the tangent ratio button. And that's going to give us a decimal ratio. 5 decimal spots when you do this. So we're going to say 0.42447. So we're going to say 0.42447, and that's equal to the opposite side, which is x. I used the wrong color there, but that should be the opposite side, over the adjacent side, which is 27. Okay, we can make any number into a fraction, including this decimal, by putting it over 1. And then we're going to solve this by cross multiplying. 1 times x is simply x, and 27 times that decimal looks like it's going to give us our answer. So I'm going to write approximately, because I'm going to have to round again. And we're going to see how this is already in our calculator. So I'm going to save that long number. I might as well, because that's more accurate than the one I wrote on my paper. Okay, so you don't have to. You can clear this and only put the 5 digits in. It's still going to be okay, but this is the more accurate number. So I'm going to write times 27, and that gives me 11.46. So we're going to say 11.5. So we're going to say x is 11.5. So we're going to say rs, that's the side length, is approximately 11.5 inches in length. And that, ladies and gentlemen, is how you use the tangent ratio to solve for missing sides in a right triangle. I hope that really helps. Please let me know if you have questions further than this.